is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello everybody, and welcome to SkyTour Livestream. It's Marc D'Antonio here, the tour guide for SkyTour Livestream, along with our good friend and cohort in crime, Darrell Mason. Hello, Darrell.
Hi. I've never been convicted of a felony. Hello, everybody.
That's what you tell everybody.
Yeah, it's true.
That's true, actually.
Of a felony.
Oh, felony, right?
No.
Okay, that's different.
Well, actually, I have never been arrested. I have gotten a few traffic tickets in my life, and that's it. When I was a Cub Scout, we got a tour of the old county jail one day, and
Okay.
you talk about scared straight. I have never seen the inside of a jail since.
I was not arrested. I was taken in by the police one time in my life, and it was for a complete accident, actually. We were shooting cans off of a fence with BB guns, completely oblivious, totally oblivious, stupendously, colossally ignorant of the fact that there was a parking lot on the other side of the fence.
Uh-oh.
And we were dinging and pinging windshields without even realizing it. And one guy was eating his lunch in the car, and all of a sudden, chapoo, the windshield got cracked. And he called the police, and the police came walking up the driveway and said, "What are you two idiots doing?" And we're sitting here with our guns. Now, those are the days when they don't just draw down on you and shoot you. They basically were saying, "Give me those guns." And he took them away from us and put us in the car and took us down to the police station. So my father was good friends with the chief, and so the chief said, "What do I do, Leo?" That was my dad. And I heard over the phone like, "Rah, rah, 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 rah." I couldn't hear because they had us in a holding cell to scare us straight. And trust me, we were scared. So it was very funny because, well, not at the time, but the chief Frank Roach was his name. Roach, that was actually his name. He basically said, "Okay, Marky," that's what they used to call me in those days. "You're here with us for the day. Your dad says you're staying with us." And I was in a cell with these black bars, and I was like really scared. I didn't know what to do. And Davey, my friend, was also in there, and all he could say all day long was, "My dad's gonna kill me. My dad's gonna kill me." Well, we had 2 BB guns, and the BB gun I was using was an old Daisy pump thing where you actually would pull the thing down, and the spring gets cocked, and then you fire, and the spring pushes the BB out. The one Davey was using was a pump action, where you pump it up. You could go to 21 pumps and really put some pretty high feet per second on that BB. Well, when the end of the day came, the chief brings us out of the cell. There were 2 little kids. I think we had to be 11, 10 and 11. And Davey begged my father to take him home too, because he didn't want to have to call his father. And my father said, "Okay." Well, anyway, the chief pulls out the guns and says, "Okay, which one's which?" And I said, "Mine's the Daisy." "I mean, this little one here?" "Yes." "The spring-loaded ones?" "Yes." And one of the other police officers takes it and says, "That thing?" And he cocks it, and he shoots the butt of another police officer standing by a file cabinet. And all it does is bounce off his butt, and the guy turns around and says, "Hey, cut it out," and he goes back to work. He says, and then that cop says, "This isn't the one that broke the windows." And then they held up the other gun, and it was a pump action gun, and they all said, "Oh yeah, that's the one that broke the windows." And that's the gun Davey was using, not me. Well, anyway, I borrowed that gun from a friend of mine to give it to Davey so we could shoot cans. Well, the chief asked me whose gun it was, and I told him I can't tell him. And he asked Davey, and Davey said, "Well, Mark let me borrow it." And then they came back to me, "Marky, whose gun is this?" I was like, "No, I can't tell you. I can't tell you, Chief. I can't tell you." And my father grabbed a little hair on the back of my neck and just picked it up and pulled it up. Oh, the pain was immense. And then I started to cry. And all right, I'll tell you. Whose gun is this? Now, everyone in the police station is looking at us. Okay? There had to be like 10 cops in there, plus the chief. And I said, "It's your son's gun, Chief." And it was. So he went, "What?" And the place erupted in laughter. It literally erupted in laughter. And the chief said, "All right, shut up." Oh, my gosh. And he goes, "I thought I recognized his damn gun." And he smashed it on the ground and said, "Damn him, Donald," his son, Donald. Anyway, Donald didn't talk to me for about 2 years after that because I couldn't be trusted with his BB gun. His dad smashed it. That's the BB gun story.
Yeah, the police station in my hometown, the police headquarters.
Yeah.
You'd go in there. I was there for, I don't remember what it was. I wasn't in trouble. Just I had to ask a question at the front desk. Mm-hmm. They built a new police station there a long time ago.
Yeah.
And when you go into the front desk, there was a huge picture of Granny Irene Ryan from the Beverly Hillbillies
Jethro!
sitting on the wall behind the front desk.
That's hilarious.
And it blew people's minds, and they'd go in there drunk or something and see that. She Irene Ryan sort of adopted my hometown's police department. This was back in the days soon after Beverly Hillbillies, or still during Beverly Hillbillies, and she was a patron of theirs, and she gave a big, huge portrait, and they proudly hung that thing behind the
Oh, that's hilarious.
desk on the wall.
That is really cool.
I'm sure that freaked out many, many people through the years.
Oh, I think it would have. It would have freaked anybody out, including two young guys that use BB guns. But that's the one and only time I was ever in any trouble. And it literally was a stupid decision. It wasn't even like a malicious act, But anyway.
I have to admit, I got in trouble with the law once. It's a long story. I won't tell it now.
Okay.
It involved a junior varsity football game in a small town down in the Ozarks. I'll tell that some other time.
All right. You got me wondering, and then he wants to know, too. Once he was a little green ball of clay. Gumby, you should see what Gumby can do today. So, hello, folks. Welcome. I know I've been talking to Darrell. This object we're looking at right here, this is a Wolf-Rayet star, which is this star right here. It's this guy right there. You see two bright stars there. It's that one there, the bottom one. And what is it? Well, it's a star that's very hot, and it's expelled its outer layers, and it's heading towards supernovae at some point. It's going to go off as a supernova eventually. The star very likely is only a few million years old. They're very massive stars. And this is this green part here. This is some of the expelled outer atmosphere of this star. This red is not. This red is part of the nebula, the diffuse hydrogen gas that's ionized that it sits within. And we see a lot of these all over the place. We see the Dolphin Head Nebula. We see Thor's Helmet. We see the Bubble Nebula, which is a Wolf-Rayet star. I've confirmed that, by the way, Darrell. So it's showing that as rare as these types of stars are, there's actually quite a number of different kinds. And if you tune in to SkyTour Radio Sunday nights, at 6 p.m., 6 to 8, we talk about things like this. And we're going to do an entire show on Wolf-Rayet stars, because they are literally the most dangerous place to be near in the universe. Black holes are bad, yes. Neutron stars, pulsars, awful. Gamma ray bursters, yep, terrible. Fast radio burst sources, magnetars, absolutely horrendous. But these stars are right up there in the danger zone, let me tell you. So I gotta say, first of all, I have to say hello to all of the folks that came in here. Lubo from China. Hey, Lubo, how are you? You were first. That is correct. And SMA Sky is with us. How are you? And Daisy and Zoe are with us. Nice to see you guys as well. And of course, Michael Hedrick. He's now a veteran, of SkyTour. He's been here for a long time, and Izabela as well. She's been here almost from the very beginning of SkyTour Livestream.
Hi, Izabela.
Yeah. Izabela's very talented. She's doing a lot of stuff for us, and if you've seen the Instagrams and Twitter, or X, I should say, instead of Twitter, right? If you've seen the X and you've seen the Instagram and some of the other locations, you will have seen her work as pertains to SkyTour Livestream. She's creating these amazing videos, which are just phenomenal. C&D Boy is with us. Sam S, Cyclone. Nice to see you guys. Thanks for coming out. we're going to look at some neat stuff tonight. And we got Patco Incorporated. Never caught a live one. Always kind of skipped through the vids as a lurk monster. Well, no longer. You're not lurking anymore, man. No. Yeah.
Your remarks about the Wolf Rayet star reminded me. I saw some article today. It was a general interest article, but it might have been space.com, but
Okay.
they weren't good about details. It's written for the layman. Said Earth got hit by a huge dose of X-rays sometime recently, and I couldn't pick much detail out of it about particulars of what happened. But
About when?
when I thought it was just recently. I'd have to look into it or find that article again. I saw that this morning.
Well,
It may have been from the Vela supernova remnant. I forget.
Okay, because I know that we did get hit by some. I can't remember the energy that struck us, but it was enough to generate electric currents in the crust and cause some effect on the planet. And I didn't think it was X-rays, but I'd have to look it up and find out.
Yeah. This article, at one point they said X-rays, at another point they said gamma rays.
Okay.
But I guess they didn't make it to the ground, so.
Okay. Yeah, the
No
atmosphere can stop some of it.
Yeah.
There's that green ring. See that beautiful green arc, guys? And look at all the stars, okay? If you think about it, as our good, dearly departed friend Lee Spiegel used to say, every one of those dots is a sun. He was being fanciful and romantic about it, but the fact is, they are all suns. Potential, life-enabling stars. So we'd have to be careful about which ones we look at. Obviously, the Wolf Rayet star here is not one of those. Okay, and that one is not a wolf. The Wolf Rayets are not a life-friendly type of star in any way, shape, or form. Their surface temperatures are tens of thousands of Kelvin, which amounts to many tens of thousands of degrees Fahrenheit. So it's actually quite a hot location, and most of the energy coming off this star is in the ultraviolet. So I'm going to name this thing here, and then I'll give some of our friends a tour of the screen. This is a Wolf Rayet location known as 134. All right, and we're going to save it, and you'll see across the top a green bar. It's saving as an astronomical file format for those that want that, but if someone who wants it just like we see it here, then we get this ping file, and if I click on that, you will see this is the file right here. You're looking at the actual object minus the text. I say I can get rid of that text. Bing, go away. Okay, and so it's in a directory right now, but what's happening is, as we speak, this is now being sent up to the cloud, and it will be made available on our server located at skytourlive.org. You scroll down and say, take me to some cool pictures, and you will see them. So check it out. So go to skytourlive.org and check it out, and then also take a look and visit our Etsy store called SkyTour Shop. When you go into Etsy and you search, you type SkyTour Shop, just like you see it there, and two selections will come up underneath. It'll say search for things with SkyTour Shop, and then search for stores, SkyTour Shop, and do that one, and you'll come right to us. We have about 100 products up there, from mugs to blankets to you name it, bathing suits, shoes. I have a pair of sneakers that I had done in one of our gorgeous photos, and it really, really is definitely an item that gets the conversation going, if you know what I mean. So it's really cool.
I found that article.
Yeah.
It hit within the last 24 hours. If you just search Google, whatever, Earth hit by blast of energy, all sorts of stuff comes up in the mainstream media, Daily Mail, New York Post, The Independent, and it was the Vela supernova remnant, or it's a pulsar, and they did say it was a very powerful gamma ray burst. It was detected down at I forget the name of the observatory. It's down in Namibia. It's
Oh
got
yeah,
four
yeah,
small reflectors and a great big
yep,
reflector.
yeah.
Yeah.
That's the automated listening post software that they've got going on down there. It's like an automated system, I think.
Yeah, Ness or Hess or Mess or
Yeah.
something.
Now this is you said the Vela, VELA, right?
I do believe. Let me check again
Because you
here.
didn't say veil, just so people know you weren't talking about the
No,
veil.
Vela pulsar, about
Okay,
1,000
okay.
light years from Earth.
Yeah, 1,000 light years is not that far for a pulsar. Considering that a strong pulsar could irradiate and render lifeless with its energy, it could render lifeless sometimes anywhere out to between 10 and 100 light years away. Depends on the strength, you know. So pretty cool. So this guy here, then again, it's the Wolf-Rayet star. All right, WR134. You almost can't see the text because of the because of that. So it's actually that. It's the WR134 Wolf-Rayet star, right? And it's been saved out here, so we can get out of this now. I did this mostly for me to get a better image of this, and we're running it at a higher gain than I would normally do. And it was a 30-second shot, not a 20-second shot like last time. And Izabela did a very nice job pulling out a lot of this detail when she did her processing. We've created a monster in Izabela because she is a phenomenal artist already. And now you turn her loose on photographs like this, and she rivals anything I've ever done when it comes to photography in terms of processing. She's really quite good. The artist
She'll be running this place one day.
I know, right? And then I'll ask her for a job.
Is this Isabella's image or yours?
Which one?
The Wolf-Rayet star.
Wait, this image here, she processed this image when we took it last time. And this is another shot of it now that we've been collimated. So this will be a better looking image than the last one. And I already went through focus run.
So this is her version.
No, this is the actual thing we're taking a picture of right now.
Oh, okay.
Yeah, this is a live shot. This is not.
Ah.
Oh, now I see. You thought this was a photo. Okay, no. No, this is actually the live shot. You know.
Oh yeah, I see that now.
Yeah.
All right. Yeah, she did a really nice version of this image.
Yeah.
Processed image of it.
Yeah. Okay, so we're gonna save this exactly as seen one more time. All right, good. So now we can pop out of here and go into something different, and we'll do that right now. And we'll just go back to I call it our night vision mode, and you'll see why. Ta-da! So here's our screen. Okay, we have the telescope control system. You can hit north, south, east, or west. Okay, and this is the telescope computer. This is the telescope in the building. This is also the telescope in the building right here. Okay, this is me. Hello. The main view, as you saw down below. This is our stacking view and histogram and sharpening special effects view, and this is the camera operations panel down here. This does all the camera work. We can focus it here. Autofocus setups are here. We have our night vision set up here. We have this histogram, which allows us to, pump up the background and get all the subtle detail, kind of like a night vision scope would do. And we use that kind of as like a little bit of a finder scope when we're looking for stuff. All right. So that's what we do. We also have different ways to steer the scope. We can steer them by going north, south, east, and west over here, or we can bring up our planetarium, move around to different spots in this free planetarium called Stellarium, and I've connected it to our system, so that our telescope system out in the building. So if we tell it to go somewhere, it will go somewhere. It'll go there. So for instance, let's stick around here for now, and let's go see. I see this interesting little nebula here. Let's go check it out. It's nearby. All right. So we're gonna see it moving up there. You see, as soon as I tell it to go, it's going somewhere, and it's gonna move to this little spot right here, and you can see the crosshairs are now lining up on there, and that's exactly where we want to go. All right. So we're centered up on that. This red square is our field of view. If we zoom in, you can see that you'd have to turn your head to the right to read that. And that's the way this whole view looks, right? So now in here is that object that we just lined up on. See those stars up there? Let's go back. Those are in the top left. And those are going to be up here in the top left, and there they are. See them? Right there. Because you'd have to normalize this from, turn your head. And at the top left, you see those stars, just like that. And then, so that's what we got. So now, let's go and do we'll do a 25-second shot here. All right. And so I set 25 seconds there. Our gain, I'm leaving here for now. And then I will take us out of night vision mode and go into our live stack mode. And that's when you see this over here. Okay, this is the last buffer that we were using to see the Wolf Rayet star. We're going to clear that now. Hello, Corvette dude. What's up? Nice to see you. Jay Rich, how you doing, man? All right. And here we go. And as you can see, we have... Yeah, we missed it just a little bit. But let me bring it over so we can look at it a little bit more closely. There we go. All right. All right, so now what we'll do is move this over a little bit. Now we are in the process of finalizing the equipment we want for the SkyTour site number 3. SkyTour site number 1 is here in Connecticut, where I live, and that telescope is behind me. You can't see it; it's in the dark behind here, and it's being rehabbed in here while we wait for the prices to come down on materials, so we can actually build our building. Again, it wasn't a building here, a real dome, but I got tired of having the big minion on the front lawn. People were coming and taking pictures of the minion on the front lawn all the time. So we ended up selling it, and I want to put up a new one that's going to be less problematic, because the dome has a slot, and you got to rotate the dome automatically to be in front of the telescope opening at all times. And this telescope dome wasn't reliable. It's meant for someone to be in it all the time. And when I was doing that, that was fine. There we go. Look at that. When I was in it doing it, that was fine. But when I decided I wanted to do it remotely, then it became a serious problem. So I sold it, and now what I'm doing is just using what are called linear actuators. I'm going to be popping like a flower, opening a flower petal. It's going to open up 2 halves, exposing the telescope to the entire sets of horizons we have here, which are fantastic. And then we're doing the same thing out at site number 3 in Arizona. We're going to have a opening flower petal system as well. Hello, Jane Murdoch. Creeptasia, what's going on, man? So, Jay Rich, I haven't seen you here for a while. How you been, man? All right.
What are we looking at?
That looks to me like something we've seen before, doesn't it? And I'm going to go back and show you, and you'll know as soon as I pull out of this. Okay, do you got it yet?
No.
It's the Tulip.
Oh, okay.
Yep. Yeah, and so I wanted to get that because there's some beautiful dark nebula in here. The universe is full of this dark dust, you know, guys, and it's this stunning darkness, this absolutely beautiful darkness from whence life comes. And we're seeing the fundamental building blocks of life literally being built by the universe. Like if we zoom in a little bit on this part of the tulip here, see these beautiful gossamer streaks? These are all dark dust. And then the stars in here, some of the stars, it may only be one, has enough ultraviolet energy to ionize hydrogen in the region, making it glow red. And that's what we see here. And then we see this diffuse glow everywhere we look. And if you notice, there's dark dust here that's blocking our view of what's behind it. There's some dust here blocking what's behind it. And that's what we see. We see a lot of this dust that's blocking the view behind it. Except in places like this, where there's a star that's causing the hydrogen gas to glow. And so sometimes that gas will silhouette some of the dust. And sometimes the dust will scatter some of the starlight. And when it does, the nebula is a markedly blue color. Yeah. Let's see. Creeptasia says, I see you guys got new tech, new setup. It's an amazing, more definitions coming out from the new technology I saw a few streams back. Definitely a major improvement. Yes. We're using the new camera. The new camera is called the ZWO ASI 183 MC Pro. And that camera has been specifically selected because it's perfectly tuned to our particular optical system. So it's the best combination to get the best number of arc seconds per pixel resolution. All right, and it won't oversample or undersample our data. So we get really nice imagery. Now I had to go out there to fix the lens system because our lens, actually our telescope has a big mirror at the back end, but has a big lens on the front. And this mirror and this lens were kind of cockeyed to each other, and so the stars had little tails. And it's called collimation that you have to do, collimation. And I had to go out and collimate this because the other two people in our organization, Marianne and Tara, they went out and tried to do it, and they did exactly what I told them to do, but it turns out that what was needed was something they couldn't do, and so I had to fly all the way out there. I got there on a Tuesday. I came back that Friday. It was a whirlwind trip, but boy, was it great. You know?
Mark, Izabela, and Cosmic Ray both asked, why are the stars so big and blobby?
They look big and blobby?
I guess they think it does.
Well, let's zoom in and see. Well, the guiding seems pretty good. I did do a focus run. I could probably do another focus run and see if that changes anything. But, I mean, I am zoomed in.
Okay.
And that's probably what they're noticing. In fact,
that might be.
I'm actually pretty sure that's what they are noticing.
Yeah.
Yeah, this is the full field of view right here. And that is about 1.5 degrees across and about 1 degree tall. Okay, so we used to have 4 full moons across and 3 full moons tall. Okay, now we have 3 full moons across and only just about 2 full moons tall, not even, not quite. So it's definitely yeah, someone's got the hiccups. So if I zoom in, you'll see that's why the stars look bigger and a little bit more. Because in fact, we can zoom in till the stars just become blobs entirely. So that's what's going on there. Benjamin Izabela says, "Bless you, Darrell."
Thank you, Benjamin. Sorry,
Yeah.
I had dinner a little bit late.
That's fine. I'm glad you could join us. So you see, this is now more what you guys are looking at. I had zoomed in. Look at this zoom up here. Okay, so you gotta see the zoom when it's sitting here, when it's at like say 25%. That's pretty much zoomed out. And if it's anything higher than that, then we are going to be zooming in to a section of the image. So, pretty cool. And we're getting a lot more detail in this region right now, which is pretty. Look at that. It's almost looking three-dimensional in here. Let's see if we can pull out some more detail. This yellow line here intersects the data, and everything below it is brought in. So all this is not being looked at, but this is our black level right here. So if I move it to the left of that curve, then things get brighter. Okay, move it way far to the left, and it becomes like light pollution city. Like that's what it would look like if it was a light polluted region. We have a very dark sky out there, so this is a simulation of that because of the nature of how processing works. So if we can move, this white curve is the average curve of the red, green, and blue curves you see here. And so if we move it just to the left of the peak, we won't lose any detail, and it'll be as good as it can be. Then we take this mid-range one. As we move it to the left, you'll see that it starts to intersect more of the data as that curve raises up, and we get the corresponding increase in detail. But you do it too far, and you end up with noise. Okay, but that's really what's there. So there's a lot going on here. Now I am running at 250 gain. The camera works best at about 150 gain. So I think it's possible that we will go back to 150 gain for some of the other nebulae we look at tonight.
Mark, Cryptasia wants to know if you might be able to look at a planet.
I would love to be able to look at a planet. This camera is a little better suited than the previous camera to do that, but we still would need a much higher focal length to see a planet with any real detail. And it's possible. I mean, I looked at Jupiter the other night with this, and I could see quite a number of cloud bands on it. So we can see some detail, but we do have to zoom in quite a bit. And that's okay. And so maybe we can do that later. We'll see. Because Jupiter is, I think it's up right now, actually. Look at this.
Give me just a sec.
Look at this.
If Jupiter is up, it may be too low for your telescope.
Yeah, I think it's in the east.
Saturn is pretty much prime time right now.
It is? All right. Well, we can try looking at Saturn and see what we can do. But I want to... Go ahead.
Jupiter is up very low in the east-northeast.
Yeah, we got to wait on that.
Saturn is in the south-southeast. It should be inside your... inside the area your scope can reach. And
the only reason we say the area the scope can reach, guys, is because, look, see the walls here? the walls of the building preclude us from seeing certain things until they get high enough in the sky. This is for the protection of the telescope and the observatory. Our flower petal arrangement, though, that we're doing is going to expose the telescope to everything. So if there's wind, we're going to feel it. So we have to... I have it set up so that I can open one side at a time and literally keep one side open a little bit and open the other side all the way, and just keep doing that to manage how the scope will perform because of the wind. Hello, Prow. How's it going? Look at that beautiful nebula. This is, as we said, this is one that's a really cool one. It's in this constellation of Cygnus the Swan, and it's actually called the Tulip Nebula. And why the tulip? I don't know. I don't think I can help you with that, because I have no idea why it's called a tulip. But that's it right there. Tulip Nebula.
Somebody evidently thought it looked like a tulip.
I guess.
Could you zoom in a little bit?
Yeah, I can. Let me do that. All right. Look at that. Look at all these filaments. Now, here's the thing. With our other camera, these filaments would not be available to us. We'd see the rough filaments, but what we would not see is the subtle detail within the filaments. And we're getting to see all that detail within the filaments now. So that's really quite something, and quite a change, a much better detail profile for what this camera can do for us. Very active region, if you notice, guys. It's got lots of dark dust here. This is not a void, okay? This is not lack of stars. This is actually just dark dust. And Cyclone has a question. What's the... you're funny. Hey, Vince Giglio, how are you doing?
You want to see something interesting? Can you back out a little bit?
Sure. Well, you told me to zoom in, so I did.
I know.
Okay. All right, back
now, look to the above the tulip and then to the upper right. At a bit of a diagonal. There, I often remark on when I see like dark lines.
Like these?
Well, in particular, there's a skinny one. It's quite pronounced to me. You're right on it there. Now slide down and to the right some. No, not there. Higher up.
I know. If only you could point.
Yeah. You're right on it.
Okay.
There's a more shallow angle to the right and down a little bit. That
Right.
It runs all the way to the edge of the screen. You don't see that?
I do right here.
Yeah, there.
I see that, yeah. Now, could that be a real thing? Maybe. Maybe.
And that's what I'm getting at. Because oftentimes I wonder if I'm just imagining things when I see like dark lines, meandering, or I've called them spider legs before and stuff like that. Sometimes they look real, sometimes they don't.
Yeah.
That certainly looks real.
Yeah. Vince says, been coughing since mid-July. Haven't been able to get out myself. How have you been doing? If that was directed to me, I'm doing fine. I talk so much, that I end up having a cough. But you also have to understand that one of my vocal cords is paralyzed. So I only have one vocal cord. Now we have voice for radio. Hey. My voice used to be a lot higher than this, but now it's lower. Which is kind of cool, It has its benefits, doesn't it? So you see here, this big, giant, dark cloud. You can see how this cloud is obscuring a diffuse nebula behind it with this pronounced area here. So this is actually in front of, it's up here, and the nebula is back here. So it's obscuring the nebula back here. That's how this is working in the universe. And sometimes they're at the same level, same distance, and they intermingle. And we see, what look like embossed edges to a dark nebula because the dark density increases, and the ionized hydrogen, the red glow, is confined to the edges because it's too dense for that glow to show through. So we see a lot of that. All right, this is really cool. We're going to save our Tulip Nebula here. Yeah, there we go. And now we're going to save it exactly as seen. Excellent. Now, when I say clear and it's gone, you'll say, well, where'd it go? It's here. It's skytourlive.org. You go up there, and you'll see Izabela or Darrell will put an address in the chat, and if you miss it, it doesn't matter. It won't hurt you. Because skytourlive.org, you scroll down to the dark gray block right below the main entry block that you see, and it'll say, take me to the cool pictures, and it'll take you to the database, but it's going to tell you how to navigate to the pictures. And you'll click in these directories, and then you'll see the photo that we just took tonight. This photo exactly like this, without the words. Okay? So we say save, and there you go. That's our astronomical file format. And then we have it exactly as seen, just like that. All right, so that's up there now and on its way. It'll be there in 30 seconds or so. In fact, Darrell just put the link up.
Izabela did too.
Very cool.
That's interesting. That little dark line I mentioned above and to the upper right of the nebula. Over on the left-hand most part of it, just closer to straight above the nebula to about 1 o'clock, there is a very distinct line of stars following that same line.
This line?
Yeah, right there where your pointer is or was, there's a line of stars right there.
Interesting.
You don't see that?
I see this line of stars.
Yeah, they continue a little farther to the left, too.
Yeah, I see that all the way over there.
Yeah.
Yeah. It's interesting. Really interesting. Okay, well, we're done with this object for tonight, for now. It's up there on the database for us to explore stars and beyond. Very cool. And now that we are going to do this, we're going to come into our image here, our stellarium shot, and let's take a look. I'm going to head up north here. I haven't looked at this lately. It's probably a good idea to look at it, just to check it out. First things first, I'm going to go to Deneb, the main star in Cygnus the Swan. Deneb is, of course, a kingpin. It's a very bright star, brightest star in Cygnus. And we're going to head to it in order to do an alignment on our telescope. I will do this from time to time, because sometimes we're looking for stuff that is not visible until you take a picture. And when that's the case, you go away. Okay? So when you take a picture, you want to be able to see the object you're photographing, and you want to make sure it's in the middle of the view. And so instead of having trouble viewing something, we will actually make sure that we hyper align the telescope, make it really, really well aligned for that location in the sky. Now, while I'm here, I will also take advantage of the opportunity to do a refocusing, because I don't need it, I don't think, but technically you should refocus after every object. Alright, there's our crosshairs. We can change to our... There we go. Okay, so now when we come into this and we center Deneb now, you can see how the crosshairs are off to the left side here. So what we're going to do is now synchronize, and you'll see that go there. All right, and now we're synchronized. We've got the coordinates set up. Everything is aligned. So now we can go to the next object and know that when we call it up, that it's going to be right in the middle of our view. There we go. All right. So now what I want to do is go to just a location. I'm in love with this location in this object called the North American Nebula, and we're just going to go to this location. So the telescope's going to move to a particular location, and it's going to move so that it's the center of this square is there, and it'll be right in the middle. So where are we? Well, we're at something called the Wall. It's in the North America Nebula, and we're searching now for a guide star. That's what you see searching, and when you start to see numbers show up, it means we're aligning in the east-west or guiding in the east-west and guiding in the north-south direction. Okay, so let's do that, and we'll make this a 30-second shot of the Wall, and these numbers should stay under 1 for this to be a good shot. If it gets over 1, it means wind is buffeting. It might be momentary. We can do up to about 2, and then you might see oblong stars. Progress bar down here on the lower right, that shows us how far along we are.
Mark, when you have a moment, Cyclone has a question for you.
Okay, I see that now. Oh, there it is. Look at that. Okay. So let's first now go into our live stack, and we'll remove the last buffer. All right. And so the next image will be the first one in our stack. And when I say stack, what we do is we take an image, take a second image, align it with the first, line up all the stars, and then just do that over and over and make an image sandwich. So any of the dark detail that's hiding, any of that dark detail will be brought up higher and brought more to the center of attention, like these areas up here. And the areas that are bright will also have, that's gorgeous, we'll end up having a much more prominent view to you. Okay, I'll get to you in a second, Cyclone. This is beautiful. I mean, you see this subtle detail in here, and you're going to see more and more of it. As soon as the second one gets stacked, you notice how that modeling noise gets way reduced. That's why stacking works, because it reduces that random noise that's in every single photograph. Cyclone says, if there was a black hole the size of the tip of a pen, would it grow bigger the more you put in it? Also, if you put a finger in the black hole, would it get stretched out? If you had a way to hold a black hole in one location, then it could do some damage to your finger. Yes, it would probably rip it to pieces, as it's going in. Yes. And would it get bigger the more stuff you put in it? Yes, that's how black holes grow. And you can calculate the size based on the amount of mass that they have. And that size is determined by a formula for a quantity known as a Schwarzschild radius. Schwarzschild was a scientist who, of course, did a lot of research with black holes, and we know that calculating the Schwarzschild radius is something you can do. The Schwarzschild radius for the black hole in Messier 87's core, for instance, that supermassive black hole, the Schwarzschild radius of that is literally the radius now, not the diameter. The radius is about 2.5 to 3 solar systems in size. Now we're talking, Sun to Pluto. 2.5 to 3 of those in radius. It's double that in diameter. It's a massive, massive black hole, and that's why we see these usually only in the centers of massive galaxies. So hopefully that answers your
I dare
question.
say a black hole the size of the ballpoint on a pen would probably kill you instantly. Probably pull you into it.
I think you got to there's another thing to understand too. If it was a micro black hole, size of a ballpoint pen, the gravitational field is actually gravity's a weak force, right? So if you brush your finger through it, it wouldn't just go bleh and pull you in like you're going through an airplane window that just burst. I think you could pass your finger through it. It might get yanked, but I think if you move fast enough, it's small enough that your inertia would actually allow you to escape it. And it's a philosophical question, actually. So it's possible what you say is true, but I would think that you'd have a way to survive it initially anyway. But as it ate a piece of your finger, it would grow, again, by the amount of mass that it absorbed. Now, black holes are always evaporating. That's the other thing. And so a black hole the size of a pinhead would actually evaporate. And how long would it take? There is some formulae to kind of deduce how long it would take a black hole to evaporate, but micro black holes, the ones that are really tiny, we call those MBHs. Micro black holes, they are only around for a few nanoseconds. And if they can exist, we haven't actually really been able to harness them yet. But they're out there. I'm gonna do something else here. I'm gonna sharpen this up. See, all this detail kind of looks fuzzy a little bit. Let's change that. You ready? Watch this now. Pow! Look at that. Look how sharp this all became. Much more detail visible. Much more detail. We could go crazy too and pump that way up. All right. Now look at how much detail's in here. But we tend to keep it down to a more reasonable size. That's pretty. Looks great, Darrell.
Mm-hmm.
Yeah. I'm going to add some contrast here. I'm going to pull in our black level. Stay to the left of our peak so we don't make those blacks ultra black, because that's actually brown. Okay, this dust is brown. It's not black. And now if we pull in our mid-level and pull out some of those darks, then let it settle out, now you'll see some real detail in here.
I dare say a black hole the size of a ballpoint pen point, you're talking about a planetary sized mass. And I don't know how well that would work.
Well, okay. A micro black hole is not a planetary sized mass. That's the thing.
I'm not talking about a micro black hole.
Okay, but
I'm talking about a black hole the size of a ballpoint pen ball. I mean, that's about a planetary mass right there.
well, I'd have to look at the numbers to know how big it is. It might be a planetary mass, but you couldn't, like, if you had a planetary mass, like a black hole that size, and you replace the Earth with it, then what you're saying is, say it was a planetary mass like the Earth, that the moon would continue to orbit that little tiny black hole. And I'm not sure about that, actually. I don't believe that would actually work that way.
I didn't say that.
Well, you said a planetary mass, and it doesn't matter where the mass is. Planetary mass still has a certain amount of gravity. So if you could put a black hole where the Earth was that had the mass of the Earth, the moon would continue to go around it just like it is now. It wouldn't notice any different. And yes, it'd be a lot smaller than the Earth. What size would that be? Well, we'd have to just calculate the Schwarzschild radius for that mass, and we'd know. That's actually a good idea. That's a great idea. We can do that. If you want, go find the Schwarzschild radius calculation and put in the mass of the Earth and see how big it would be.
Be about the size of a ping pong ball.
Okay.
So small, something a little smaller than Earth to be the size of the point of a ballpoint pen.
Yeah, I think the moon would still be too big, too. The moon's density is about that of the Earth. The compositions are very close, actually. That'd be interesting. I love those thought problems. I mean, and they're just really cool. All right, let's zoom in on this. This is the North American Nebula area known as the Wall. Look at these subtle streaks of dust. Now, you might say, where's that coming from? Why is it laid out like that? Well, keep in mind that this dark dust you're seeing there, all of that dust came from supernovae. And the production of dust in the outer atmospheres of very large red giant, supergiant stars that may have gone supernovae. And all that dust reached into the interstellar medium finally. And mostly, it's a mix of carbon molecules and silicon molecules, more carbon than silicon, and the carbon atoms bonded to each other to make a carbon-carbon molecule, and then those compounded and merged with other molecules out there, and then ice started coating them. Ice is from space. There's methanol, formaldehyde, water ice, carbon dioxide ice, and these ices just went on the surface of these dust grains. And so these dark nebulae, which I've said time and again, these dark nebulae are the place from whence life comes. This is where most of the materials that form planets and stars, when you have hydrogen mixed with them, they come from. And so here we have exactly that. We have a vast hydrogen cloud that's ionized and glowing red, and we have vast clouds, more vast clouds of black dust. So it's really quite incredible what we have here. And it's actually incredible that we can show this to you, because this is live. This is not, this isn't a photograph we're just putting up and talking about photos. We took this photo just now.
I have a possible target for you, Mark.
Okay.
James Dugan just asked about this. He saw the Shark Nebula somewhere.
Oh, we've seen that, yeah. It's a dark nebula, a Barnard object, I believe.
It's in Cepheus. I have a LDN number.
Okay, it's a Lynn-Stark Nebula. Okay.
Whatever you've done here.
Yeah. Okay. Okay, this is good. We'll do 23 shots of this. Yeah, this is the wall, and the guiding is very good tonight. It looks really nice. I do know there's some wind out there, but so far it's not affecting us badly. Let's zoom in just to take a look at this. Look at this giant spire, okay? This is really something, okay? And again, this is the North American Nebula that we're looking at, a section of it. We'll put this up here. Wow. So this giant spire, this is several light years in size, okay? right here, this spire. That's several light years in size. Really cool. And the wall is quite a few light years in size. And the thing is, if you flew through this, you wouldn't even know you're in it. It's like a cloud, except way, way, way more rarefied, as in to say, less dense. Whereas you can have 10 to the 19 atoms per cubic centimeter in some air, or even more. Here, the amount of atoms you have per cubic centimeter is anywhere from 30 to 30,000 atoms. And that's a lot less than 10 to the 20th atoms. So yeah, it's pretty much the reasoning behind which the universe has some very different things that it can show us that we'll never see here on Earth, because the atmosphere is too dense and the density is way too high to show some of this. Okay, so this picture, we're done with this image, and we'll get out of it. And we'll go back to this, and now we're going to go to the Shark Nebula. There we go. And Darrell, it's which LDN is it? I'll
1,
actually
2, 3, 5.
Alrighty, let's bring up the LDN chart additions. We'll add Sharpless to it. We'll add Barnard, and then we'll add the LDNs. All right, I won't add the Linz Bright Nebula to it. We'll just do the LDNs. As you can see, there's plenty of them. Okay, so this we want LDN.
1, 2, 3, 5.
1, 2, 3, 5. I thought we have gone there, but I think that's so long ago. It's so long ago that we actually didn't. We didn't stay there for long. Yeah, the Dark Shark.
Dark Shark.
All right. Well, we're gonna head there now and see what we get. Right.
Okay, cool.
All right.
Since CPS, that's just above Cygnus.
Yeah, it should be right up there. And there we go. If you look at the telescope here, you're gonna see that it's gonna lean over toward the north. Okay. In this upper shot here, that way, heading out toward the back of the building, is north. Toward us is south. That way is east, and that way is west. Okay. All right, we're at 55% on our sensor. Let's go back to 25%. And we'll take a finder shot here of 35 seconds to see what we got. It doesn't matter that it's guiding or not, because we're not going to keep the photo. It's just to show how close we are. Actually, we should be able to see here. Let's zoom in a little bit. And it's upside down. We got those two stars there. That's not them. No, we'll see in a second.
You synced on Deneb, didn't you?
I did. So it should be pretty close. It should be pretty close. All right, let's. Oh, I should have done the stack. Sorry. It's all right. Wait until you see that process, guys. All right. All right, here we go. Let's see what we got. Let's do this. I think this is it here. Yeah, there it is. See that dark cloud? That's it. We just have to move a little bit to the left. All right, so we'll do that. We'll move it a little bit to the left. this bright star should be about there. So let's do that.
It looks very much like the head and mouth of a shark.
Okay.
There's a particularly dark patch in the image I'm looking at, which I guess the shark's eye.
Mm-hmm. Okay, we're gonna move this over. This should be good. A little south, tiny bit. All right, and while we're here, we're going to do a focus run. So what we do is we defocus the image, as you can see, little donuts, and then we will tell it to scan through a whole bunch of focal changes until it finds the optimum focus. So it's going to build a parabola, and you'll see it start here and end up going to here, and then it's going to automatically interpret where that lowest spot on the curve is, and that lowest spot, go away, that lowest spot will be the point of perfect focus, and more stars will be coming in as it gets more focused, and then as it goes back out of focus, going past the focal point, the number of stars will decrease. Okay, look here, you can see that we have the beginnings of our parabola here. You can see that it's moving like this, and it's probably going to put a line right here as the best interpreted location. There it is. That's the best focal point, and we've done 9 of 12, and now 9 of 12, it'll say 10 of 12. And it stopped early because they've already found the best focus. So there we go. So then I tell it to do best focus, and you'll see this focus point drift back to all the way to the other end, and then come back to the center. And now the stars are completely focused. You'll notice the number of stars we have. We have 95, 92. Okay. Okay, so now let's do another shot of 35 seconds. Okay. And then we should be able to... Okay. So the shark now, these two stars now over here. So we're going to see much more of this. Okay, so we'll clear this. Yellow progress bar over here, you can see moving up. Yep. Thank you, James Dugan, for that suggestion. We've looked at this before, but it should look pretty nice, as we're going to find out. Here it comes. There we go. Look at that. There's the shark. Let's color correct too. Okay. Now we bring this back toward our peak. And you see how that's actually gonna make things look a little better. And let's drag this down. Let's see if we can pull out more detail in this. See the object right here. There's a reflection nebula down here. That's the blue. There's another one up here. there's dust in here, and these stars are getting their light scattered by the dust particles, and that scattering looks blue. And for the same reason our sky is blue. Same exact process. Just in space versus on Earth. Let's do this.
Well, I see a dark patch. I don't see a shark yet.
Yeah, we need to let this play out.
Yeah.
See, the full extent is here. And I'm at a gain of 250. Hey there, Louis Ta. How you doing? He says, Jaws theme soon. Dun 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 dun. Oh no, that was Amok time with Spock. Da-da, 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 da-da. Da, 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 da. You can see the glow here. It'll make itself evident in just a short time. Let's see where it wants to go for the processing.
I sent you a thumbnail of what it looks like.
Okay. I wish I could look for it. Okay. There we go. We'll let this come in a little bit.
Mark, would you excuse me a moment, please?
Sure.
Be right back.
We're ready. We photographed this, oh gosh, it had to be a year and a half ago, last time I photographed it. And it was actually pretty interesting, but it is quite a dim object. And we could actually push and get some more detail out of it by doing this push where we move these two lines closer to each other. And if I click that line, this over here, I can actually really punch up the processing. And so you can see this subtle brown cloud here. And that's what we're looking at. Okay. I'm visiting, I'll be at the observatory again November 2nd through the 9th. I'm going to take care of creating some special images called dark frames. And they will subtract all the camera-related artifacts from the images dynamically. Right now, you look down here, it says apply flat. We actually are applying a flat frame image to this so that we get rid of the natural lighting up of the center of an image sensor and the vignetting around the outside edge. That's natural. It happens with camera sensors. Ray, I think Ray asked a question, how would we find this in the database? I think that the shark image here was a lot older than our database. So this might have been prior to cataloging. We picked a year to start with for the cataloging, and it might have been outside of that particular cataloging year. We didn't lose any of the data. The data is still there. But I think we just selected 2021 as a starting point. And then what we want to do is, from there, after picking 2021, well, we put in all of 2021 and 2022 and working on 2023. Because there's so much to do. So much there. Okay. Dark nebula require longer exposures and more sensitivity to get them. Welcome back.
Thank you.
And Michael Hedrick says, do you think our sun will become more or less active in the coming cycles? Good question. You know what? If past history is an indicator, then we know that we can't predict what it's going to be. We don't know what the sun's going to do. We do know where it is in its life, and we do know that it's a stable hydrogen fusing star right now. And it will be for about 4 to 5 billion more years. So
I've heard the sun described as a mildly variable star before.
Oh yeah, well, I mean, if you count the 11-year sunspot cycle, we have a wax and wane of energy from the sun. But in terms of comparison to other variable stars, it doesn't have some variables are called irregular variables. Okay, and our sun would be kind of a regular variable when it comes to, say, the sunspot cycle, causing an uptick in solar activity and then a quiescent sun every 11 years. But there's these big cycles. Now, who's to say that that particular cycle isn't a cycle that can change? You know, as the sun matures, maybe it'll change. Maybe the sunspot cycle is new, and it only happened since the dinosaurs. And of course, there were no dinosaur scientists out back then watching the sun to see. So we don't know the length of the cycles, how they originate. We have theories as to why we have a sunspot cycle. It has to do with the magnetic field lines, actually, in the sun.
We've seen variations before, the Maunder minimum, stuff like that.
Yeah.
All right, I can see the shark's head now,
That's up
and
here.
its mouth. And that dark spot is what I saw in the images, the eye.
Yeah. This is
That's,
the whole...
That's his nose at the upper left end of the dark patch.
Yeah, right here. And it goes like this. Ray, do a query in the database right now to find whatever you're looking for. And you can query in a variety of ways, because we capture all the data from the camera and the shot, so we know what we're looking at. And so you can actually query all North America nebula shots over the last several years, and you'll get a big list of them, along with links to the images. We have those out there too. Hi, Gladys. Hey, Jeremy. What's going on?
The shark's mouth is open. His lower jaw is hanging down to the below the nose, sort of toward the lower left of that dark blob.
Okay. Let's see what else is here. All right, let's darken up the background a little. There we go.
Oh, it's starting to come out. You see his line of his lower jaw pretty good now.
Yeah. Let's see here.
I could almost kind of see his dorsal fin too. I get what fins confuse me. The one on the top of his back.
Yeah, that's the dorsal.
No, it's farther back.
Oh, this one?
Farther to the right. To the right. To the right.
More?
That area right there.
RJP, how you doing? Ray, we don't have a client yet, but for in terms of the database, we're doing it within a SQL query generator into our database. We're working on getting a front-end GUI, graphical user interface, for those of you who don't know, for the database, so we can actually search for objects in the database by date, by name, by location, by constellation, by a variety of different options, whether they're a nebula, dark nebula, planetary nebula. So, oh, Gladys, I'm sorry to hear about the funeral to go to. Okay. So let's see here. That's really pretty. Let's see if we can drag out more data. Maybe a little bit more this way. Oh yeah. Okay.
See the lower jaw quite distinctly. His mouth is pretty wide open.
Is this isn't the lower jaw, is it?
Yes, that is his lower jaw.
It's quite a big one. It's like a basking shark. Wow.
Actually, about the front half of a shark. And the fainter parts of the dark nebulosity over on the right side, I kind of see his top fin right there.
Mm-hmm. Wow. Well, this is interesting. And you can see this beautiful reflection nebula up here. Kind of reminds you of the Pleiades, this one and this one, where we have that, it looks like a brushed dust patch across the stars.
Yeah.
And that's, again, due to the starlight being scattered by the dark dust particles in this region. This is cool. All right, we're at 25.
For the suggestion, James Dugan.
Oh, we're just saving it.
It's pretty neat.
Yeah, we'll process this and see what we come out of it. Let's move on. It doesn't have the same kind of punch that we'd like to see, but that's because we didn't. I didn't set the gain higher. We could have set it a lot higher. All right, so let's go back to our planetarium shot here. We're in Cephas now. I actually wanted to go back to the cave.
That's a good one.
Yeah. because we haven't gone to the cave since. There we are. Yeah, and we got some other beautiful objects over here. All right, we're gonna head to the cave now. First things first, let's get our camera telescope all set up. All right, and now we go. You see the telescope moving up there. And there comes our crosshairs. There we are. I think this is up here. I think it's just up above. But it would be safe. What I'm going to do is I'll just take a quick shot. I'll do 20 seconds. Do a 20-second shot. And we'll stack it just so we can see what we got. We'll get rid of the previous stack. Yeah, there's a lot going on in there. Alright. Now let's see. Yeah, we are. That's what we want. It's actually not a bad composition. I'm going to move it a little bit to the left.
Almost like a circle of stars around that one lower left of center.
Oh, like in here?
Right about where you are now.
So like this?
No, a little farther to the left.
Oh,
you
here?
can see it easier before you.
All right.
The image got bright.
All right. Let me pull us to the west a little bit. Oh, I gotta go back to 1 second here. So it's moved some already. There we go. All right, and a little more. And then we'll just kick it up just a tad. Michael Hendrick says, Cave Nebula, do you have any cave stories? I have cliff climbing stories, but I don't have any cave stories. Actually, I do. We were hiking up a mountain, and we saw a cave in the side of the cliff. It turned out it was a famous cave called King Philip's Cave. And it's rumored that King Philip sat in this cave overlooking a large plain where a battle was taking place. Something like that. I don't remember the details. And we had to climb up the cliff to get to the cave. And the cave had a sloping floor like this. And if you slipped, you'd fall and go right out the cave, out into the abyss, and fall to your death. Well, we got into the cave, and I gotta tell you, it's nerve-wracking to look at the mouth of the cave and all loose stuff inside the cave. And if that started moving, you weren't going to stop. So it was really, really nerve-wracking to sit in that cave. We did get out, and we climbed with hard hats, and we staggered so we wouldn't, knock rocks on each other. But we ended up, okay, this is good now. We ended up having a singularly bad time, because during that time, as we were climbing out of the cave, I distinctly remember someone yelling, heads up, or a duck, or whatever. So, of course, I looked up just in time to see a rock hit me on top of my, right on top of my head, but I had a hard hat on. So it stunned me, and the next thing you know, I'm falling, and I see the cliff face going by. So I grab with my fingers, and they slide and slide and slide, and then bam, I catch a little ledge. Oh, that's beautiful. This is going to be a pretty one. And the ledge is 2 inches wide, and I'm looking for a foothold, and I find a foothold and realize that falling and falling I felt was literally just the fact that was the ledge I was actually standing on. And I fell my entire height and landed on it with my hands. It felt like forever. That was the weirdest thing. So anyway, that's my cave story. I also used to rappel from cliffs to actually get into veins of amethyst and quartz veins and stuff to get amethyst crystals and stuff. Never had any problem there, so that always went well. I don't do that anymore.
Where I grew up at, there were tons of caves.
Mm-hmm.
So a lot of limestone down in the Ozarks, and
oh yeah,
limestone and caves. I've been in a number of tourist attraction caves.
mm-hmm.
Some big ones, some small ones. Went spelunking a few times, and I think I got my curiosity satisfied pretty quickly. Spelunking in wild caves.
Yeah, and I just couldn't, and I couldn't bring myself to crawl through spaces that were only high enough for you to crawl through with your head turned sideways, and you get stuck, so you have to plunge that walk. I can't do that. I won't do that.
We went in a cave under a river once. That was kind of interesting. It was wetter than heck, very muddy, and you had to kind of slide down a sort of a natural slide at one point to get to the bottom, and then it was really hard to get back out.
Yeah, I would say.
And we were all really covered in mud by the time we did get out.
And a flash flood comes and you're dead. Wow. I remember when I was younger, I thought, wow, it'd be cool to go in caves, and I did a few caves. But I didn't see the allure. Especially when I've been to many Howe caverns. I've been to many other caverns, actual Luray caverns. I've been to many of these different locations. But I just caving on my own with friends. Tried it, and I think I asked a question which freaked them all out at one point. I said, what happens if our lights go out and don't restart? We'll never get out of here. And everybody was just quiet. And they say, well, no, we got batteries. Okay. And how will you change them if the lights go out? How will you access them? And if you drop one, you won't find it. We left shortly thereafter. I might have freaked everybody out. I just like the worst possible thing is to have your light go out in a cave.
Let me tell you, try being half a mile underground.
Yeah, you were in a mining world. You remember?
Yep. And you go back in the absolute back end of the mine.
Mm-hmm.
And turn your lights off, and absolute darkness.
Yeah.
I mean, not a ray, not a glimmer.
Yeah.
Not a thing.
You just get the phosphenes from your eyes in your brain generating a little like the astronauts used to see.
Yeah.
Well, cave is looking pretty. This is definitely going to be a pretty shot. Look at this. It's three-dimensional now. It's getting really pretty. Wow, the cave. I was watching some caving videos the other day, and they were going down this chamber where they had to lay down on their bellies and snake themselves through by just pushing their toes along. It's like, why are you going in there? Don't do it. And then at one point they were coming through, and a flash flood came through, and the cavern was filling up with water, and they were trying to get out. And they got to the point where the cavern that they walked through now had water all the way to just below the ceiling, and they had to go through with their heads above the water and the ceiling right here, trying to stay above the water, above the and they managed to get out. And they viewed that as sort of like a cool thing. It's like, no, stupid thing, not cool, stupid. You know, I was just not. I quickly got my fill of it too. Let's put it that way. Wow, this is really pretty. Notice this bar right here. This sharp delineation. That's pretty cool.
And the one going up and down just below it.
From here?
Yes.
Where's the one going up and down?
You're right on top of it.
This one?
Below.
Okay,
Going
below.
up and down.
I don't see it.
It's right in front of you. You're almost on it. Just to your right.
Oh, you mean this?
That.
Oh, okay. That's going at an angle. All right.
That's as much a bar as the other one is.
Yeah, but you said going up and down, and I'm looking for up and down, not diagonal. Sorry. I didn't know what you meant. Wow. This is very cool. And we come down the bottom of the cave, and we've got this this little feature right here. This right here is what's called a Herbig-Haro object. This right here. This is a new star being born. And when stars are young, they're very temperamental. And so they could cause nebulae to glow. They could actually expel nebulae through their north and south poles. James Webb just did that. It was HH121, I think. Or no, HH211. The latest one that the James Webb found. And we talked about it on SkyTour Radio the other night. By the way, Darrell, there's no show this Sunday because Bill is not going to be available. Our producer.
All right.
Okay. I also wanted to let you know I'm going to be the resident astronomer at another radio show called Night Dreams Radio, and every 2 weeks I'll be on. I was just on last night, which is why I didn't stream last night, because it was like from 10 o'clock to 11 o'clock, but then the host and I talked for another 2 hours after we got off the air. So it's Night Dreams Radio with Gary Anderson, and so every couple of weeks I'll be on there doing astronomy stuff.
Is that on KGRA or somewhere else?
No, it's a syndicated show, so it's all over the country. I actually don't know. I should know that. I don't know the answer, but it's cool.
It's a neat picture.
It is. It's looking really nice. This is 46%. Let's actually go out to 25 so we can see the overall nebula. So there's the overall nebula. Let's process it the way it wants to be processed. Okay, then let's pump it up really strongly to see what's actually there. You can see there's all kinds of detail here. This detail's already there. It's just not as bright. Here's a beautiful nebula here. That's a reflection nebula. And as we move a little farther in, darken up the background a little bit. Okay, you can see that. That's really pretty. look at that. So I was talking about those blue nebulae and how you see fringes around them. This is an example. This dust is scattering starlight, and so it scatters only the blue part of the spectrum from a star, in the same way that our atmosphere only scatters the blue light from the stars, or from our star. And so we're seeing the blue sky effect, but in a dark nebula, thousands of light years away, right? And so this is a very, very nice nebula. Let's bring this back down for a second, and you can see it a little better now. Yeah, there we go. Yeah, so that's the segment of the cave that is really pretty. And then, as I said, down below, we have the Herbig-Haro object here. This is that young star in the process of forming. Herbig-Haro objects are not yet fusing hydrogen into helium. They're hot areas. It's hot enough to ionize hydrogen nearby, and but it's not actually hot enough to fuse hydrogen into another element like helium. That threshold is about 13 million Kelvin, and it might be several million Kelvin in there. Hey, Tricia Ferreira.
Izabela wants to know what that show is called.
It's called Night Dreams Radio. Yeah. And I was on the show like 2 weeks ago, and the next morning they called me and said, "We had over 9 million downloads of your episode." I was like, wow, that's impressive. I'd like to see that for sure. So it's a big show, so I'm glad that they did well, and they actually want me to do the regular spot in astronomy, which is cool. Now I see something here, and I'm not sure if it's an artifact or if it's real. Do you see these lines? Let me zoom in on them. See these lines? I'm guessing those are artifacts of some kind. They might be artifacts of some kind. What a complicated region, huh?
Mm.
Wow. Now let's zoom out a little bit here and catch the whole thing now that I've actually given it a little more contrast. That's really pretty. And now the way it wants to be is there, which I would do this, and I would probably do this to punch it up a little bit. Oh yeah,
That shows it nicely.
yeah, it does. Cave's a beautiful location.
We still in Cepheus, Cassiopeia,
Yeah,
still up in that area, aren't we?
we sure are. What are you thinking?
What?
What are you thinking?
I don't know.
Okay, I thought you had an object in mind. Okay, Cave Nebula.
Well, if you want an object, could we? Might still be too early for Jupiter. Could we try Saturn?
Oh yeah,
I'm not even sure if whoever was asking for it is still here, but
Okay. Well, there's the
just to see
cave.
what the new camera will do.
Yeah, we can see. All right,
Very
so
nice picture.
yeah, so that'll be up there, and you can enjoy that. Just go to skytourlive.org, scroll down to take me to cool pictures, and you can have that picture in just a few seconds. Wow, Izabela, you already found the show? Holy cow. That was fast. Okay. Let's look for Saturn. Okay, so right now... Oh, Aquarius. Oh, don't we have we have the Helix?
Okay.
So we can go to that too.
Sure.
Oh, good. Yeah, that'll be the next one. Okay, let's go to Saturn now. You'll watch the telescope spin all the way around and face the other direction here. I just find it fascinating to think that that telescope is 2,500 miles away from me, and I'm running it from that far away. It astonishes me. There it is up there. Okay, we can see some of its moons already. Wow, that whole part of the sky, it's still in there. Okay, we're gonna go to the east a little bit. We're gonna have to knock down the gain to nothing. We're gonna have to drop the exposure way down to start to see some details here. This will be my first view of Saturn with this new camera, so it'll be interesting to see if we can see something. Again, it's still a wide field scope, but it's worth checking out, isn't it? Okay. So let's actually drop our gain, which is equivalent of noise. We'll drop it down to just 50. Actually drop it to even less. Drop it to 0. All right. And now let's pick an exposure. Try 2/50th of a second. All right, that's about 4 milliseconds. We can drop that down. Let's zoom way in. All right, let's go see it. Wow. Well, it actually shows it. It's a 1 millisecond shot.
Can't see the rings.
You can see the gap between the rings here. Again, it's a wide field scope that is trying to be used to look at a high focal length object. Doesn't look bad though. Very cool. Let's do this. And now let's increase our exposure. Alright, it's coming in. Okay, that's too much. Yeah, okay. Well, go ahead.
Carry on.
All right. All right. Well, there's Saturn. Again, it's not very impressive in this scope because our scope is made for deep sky objects in wide fields. But the fact that we can see the rings and the gap between the rings is actually pretty impressive.
It's probably rather like what Galileo saw when he looked through the telescope.
Oh, that's true, with his optic tube.
Yeah, and actually, that right there, you see the dot to the right. That is
That Titan?
that's Titan. And give me just a second, and I can tell you what those other ones are too.
There's other two. Hey, notice Titan's orange because it's actually orange visually.
Yeah. The two closer to Saturn on the right-hand side, Rhea and
Dione?
probably Tethys,
Maybe.
and the one on the left. I'm looking at the chart right now.
Okay.
The one on the left is Dione.
Okay. So, if we come in here and zoom in, one of the nice things about Stellarium is it will tell us all that too. So there's Titan, just like Darrell said. And then these two are Rhea and Tethys and Dione, just like you said. And you can see it in here, and you can see how the rings are kind of at that shallow angle, which is kind of what we see here.
Gladys, no, Galileo did not know that Saturn had rings. As I said a couple of minutes ago, that image we were seeing might be comparable to what Galileo saw in his telescope. He couldn't make out the rings as such, and what he saw really confused him because what he saw where the rings were projecting to either side, he scratched his head and he called them ears. He called them ansae, A-N-S-E, A-N-S-A-E, ansae. He said it had jug ears. It took later astronomers to resolve it well enough to see the rings for what they were.
Wow.
And as far as Saturn, my favorite planet, I'd have to say yes. The strongest reactions I've ever had showing people through the telescope was when I showed them planet Saturn. I've had people in tears. I've had people accuse me of having a picture cut out and stuck in the eyepiece.
Well, that's exactly what you did. Don't you be lying to people.
No.
All right, let's do this. And this will be the very first image of the Helix Nebula taken with this camera. And here it comes. Helix is the largest planetary nebula in our sky because it's the closest planetary nebula in our sky. And it's a beautiful remnant of a star that has died. There's a white dwarf at the center, and that white dwarf, oh look at this, it's being transited by a satellite going right. Helix is right there. So it's just missing it a little bit. Okay, this is a good place. Alright, so this will be a 25-second shot. Actually, 30-second shot. And We're guiding right now. Oh, it says searching, and it was working, so it looks to me like we might be getting some wind at this low angle. Well, let's try it. We can only try, right? Okay. That's the previous one. Now it's going to be here. It's going to be right about where my arrow is.
Going to have a little better image scale on the new camera too.
I know. That's the nice part. I can't wait to see what we're going to see for detail. This looks like it's going to be a good image. Here we go. Image number 1. Ah, yes. Look at that. You notice that bluish star right in there? That's the white dwarf. The white dwarf is so hot that it gives off most of its light in the ultraviolet. And it's just a hot stellar core remnant, which isn't undergoing fusion anymore. Not at all. In fact, it's just basically a inert stellar core, and there's no other stars going around this one. It's an isolated star, so this is its end state. It's going to just cool off, and it'll go from being a white dwarf to a black or dark dwarf. But the time frame over which that happens is many, many billions of years. Yeah, so check it out. Let's do some parameter shifting here. Let's also color correct. You'll notice there's a faint outer layer to the helix here, out here as well. So the way this happens is, when the star runs out of hydrogen, it'll swell into a red giant, and later, as it's evolved to another stage in its evolution, it'll pulsate and puff off outer layers, and that's just what's happened here. The greenish stuff is oxygen, the reddish stuff is hydrogen, for the most part. There's other elements in here, of course, too, because it's that outer envelope that the star was made with that it's puffing off like this. Fascinating stuff. You'll notice that the Dumbbell Nebula that we looked at the other night had a mostly greenish tint to it, because it was actually oxygen that we were seeing, and it had these striking stripes of red in it as well that we could identify as hydrogen and possibly neon. So, and that's not all there was. There's plenty more in the spectrum of the dumbbell and the helix. Alright, so what we can do is reduce the noise a little bit, zoom in,
Nice.
you can distinctly see the white dwarf's blue color. 679 light years. Is that how far this is?
I don't remember offhand.
Let me go look.
Well, give me just a second. Or you can find it in Stellarium.
Well, you know how Stellarium doesn't really, give you the right answers many times. It says 518.
694.7.
Okay. So it's closer than Stellarium. Hey, Cindy Murphy. Izabela, I'm not sure if it's tube-like. I'm not sure I buy that we just happen to be looking straight down the barrel of the Ring Nebula to see a tube-like structure. I think it more like I've said in the past. When you look at my hands, if you think of a concentric, a spherical shell going away from a star, all right. On the edges, you can't see through my fingers, but when the hands are like this, you can see through my fingers. That's the equivalent of seeing into the center of the nebula, and on the edges, you can't see through that material because it's all in the same plane of vision. But here, you're looking through a thin veil at the front and the back. Okay, so at the front and the back, you're seeing like a thin veil, and you can see through it. And that's what I think's going on in these nebulae. These are spherical shells. I think that research that showed that the Ring Nebula is actually a tube structure, and that we just happen to be looking straight down the center of it. I don't buy that. I really don't. Let me.
Sometimes they do. APOD had that hourglass planetary nebula a few nights ago, and looking at it, I mean, it was obviously, it was an hourglass shape, but it was sort of a tube shape that was pinched off in the middle. And it just jumped out at you. It was very three-dimensional.
Yeah, I can understand that. But what's the likelihood that we'd be staring right down the barrel of that long supposed tube that was the Ring Nebula? It's a very, very small chance in my view. I just don't buy it as much as, others do, I guess. Excuse me. All right. So that's a beautiful nebula, the Helix.
That's interesting.
Well,
Ray put up a three-dimensional view of the Helix, and it's sort of like a fat pancake.
Okay.
It's interesting. It's like a tire with hubcaps on both sides more than anything. And it does look very much like an eye.
Well, time will tell. I mean, we gotta be really careful about the sources for such things, too.
Well, it pretty much conforms to what you were just saying, though. That makes you feel better.
I don't have any contentious feelings one way or the other. I just have my ideas of how they formed, and I think that they're, of course, number one, they're notoriously hard to analyze. So that's a problem. Hey, Curtis Horn, how you doing? Nice to see you, Curtis. How are things going? Okay, so we have 16 stacked here. Let's see if we can catch some detail in here. Let's go to where it wants to be. Okay, that's got... let's turn this off for now. Okay, didn't make much of a difference. That's good. Actually highlighted some areas within the nebula that are interesting. Alright. You can see there's subtlety in here. There's radial spikes sticking up here, and you can see there's kind of a radial spike-looking process going on here. That's something that's going on in the Helix Nebula.
We have another interesting object that I think should be visible to the telescope now.
Okay.
Whenever you're tired looking at this.
We got the 20th one to come in right now. And there we go. Now we can save it.
It's a nice picture.
It is. Okay.
NGC 253, Sculptor.
Oh, the Sculptor Galaxy.
Should be southeast of where you're pointing right now.
Yeah, I think last time we went down to the Sculptor Galaxy as well. Last time we were here. All right.
It's Fomalhaut,
Yeah.
lonely in the south.
Mm-hmm.
There's Sculptor.
That's Bond's Galaxy. That's not the Sculptor Galaxy. I think this is actually too low to see. I'll get to that in a second. I just wanted to check something out. Yeah, it's too low for us to see with this observatory. Alright. And let's just go look for NGC 253. Alright. There it is. Alright. Off we go.
We need to look at NGC 7822 already, or 2.
Oh, it's too low yet for us,
You
I think. Yeah, look where the telescope's pointing.
Oh, you think Sculptor's too low?
Yeah, look.
Ah.
No.
Oh, well.
Nice try.
How about NGC 7822 then?
Way back up in the north. I guess we can do that. That was a Curtis Horn suggestion last time.
Yes, and again tonight.
Oh, he did? He said it?
Yeah, and
Yeah. 7822 is pretty.
put us back in Cepheus again.
Yeah, way up we go. Here we go. Yeehaw. Get that big old telescope heading up there. Let's go back to 25% their view. Looks like it's here, but let's do a quick shot to see. 20 seconds is all we need to do a finder shot. Just to make sure. Yeah, that's the Helix.
Well, hello, Vera. Long time no see.
Hey, Vera Lucia Campos, how are you? Okay, what do we got? Oh, right dead center. Look at that. Nice.
Ta-da.
Yeah, good. We're gonna crank that down. There we go. And color correct. It's gonna make it look a little darker. There we are. So now what we're gonna do is we're gonna do this as a regular exposure. It's gonna be 35 seconds. Not that. Okay, here. So 35S, and we'll come back into our stack here. There's these beautiful pillars in here, right here, that will become obvious. They're really pretty. So we'll clear it now, and you'll see what a 35-second shot looks like versus a 20. 15 more seconds. World of difference. Okay. Look at that. That's beautiful.
Star forming region.
Yes.
The emission region is Sharpless 171. Young cluster of stars is Berkeley 59.
And Berkeley 59 is probably responsible for lighting up this nebula, and partially, or if not fully, responsible for these pillars. Notice how they point at it. Even if it's going into the page a little or out of the page a little bit toward us, it's pointing at the stars. And it's because the stars are shaping these pillars with their stellar winds. Izabela, this is Gymnopedia, the song. RJP, you're right. It's tricky to capture some of these faint diffuse nebulae. Really helps to be in a very, very dark sky, though. You can see the pillars forming here now. You can see them coming out here and here. One here, also pointing back at the stars. Here. The stars are the central focus of these pillars. Let's try to do some processing, darken this up just a little more.
I think the big bright star on the left side is what's lighting up that part of the nebula.
Could be.
The stuff to the left of it. That is a, let's see, what did they call it again? One of the hottest stars discovered within 1,000, with within 1 kiloparsec of the sun. BD plus 66 1673.
Bonner Duck Merstrung number.
It's an eclipsing binary system. O5b star that surface temperature of 45,000 K, luminosity about 100,000 times that of the sun.
So that's definitely responsible for lighting up this nebula. That O star. Just like the singular O star in the Lagoon Nebula is responsible for lighting up almost the whole star. But we're also getting these pillars that are forming in response to this cluster as well.
Yeah.
Multiple things going on in one shot. Look at how it's starting to come in and looking more three-dimensional now.
Yeah. If you back out for a second, there's another little chunk of it out of view at the bottom.
Down here?
Yeah, you may not be able to back out any farther.
That's as far out as I go.
Okay.
Yeah.
Never mind. Zoom back in.
Alright, no problem. Oh, satellites. That's alright. They'll disappear. Yeah, this is really something. This is starting to really show nicely here. Look at that complexity, guys.
Familiar.
Yeah, we've imaged this before.
I know. The big pillar there,
Here.
directly under the star cluster, and then a little skinnier pillar to the left of it.
And then there's one in here. There's one here. There's one here. There's one here. There's one there. That's really interesting. Very interesting.
Izabela asks, when are the heart and the soul coming on the sky?
That's funny she mentioned that because I was about to say that the heart and soul are still coming up. If we go into Stellarium here, I can show you where they are. So we come around here. Here's the North Pole right there. And down here. Okay. I believe. I was just checking that. Oh, there it is right here. The Heart Nebula is here. Might just be visible. Let's see here. Yeah, we could probably see the Heart Nebula. And there's the Soul.
Just under
You can also see the
and,
double cluster too.
Near Perseus.
Yeah. So this is pretty. Now you can see a lot clearer, and you can see some really subtle details. You can see some really subtle details in this pillar, which you couldn't see earlier. Look at that.
I remember those two pillars before.
Yeah. Yep, we've imaged this before.
Oh.
All right, let me Okay. We'll do one more, go to 15, then we'll head over to the heart. Nice.
Michael Hedrick asks, how often is a nebula illuminated by light and how often illuminated by ionization? I would say ultimately they're the same thing. I'm sure Mark will say something different. Michael, energetic stars are they are lighting up the nebula. Higher energy radiation, though not visible light, is ionizing the nebula, making them emit light. Emission nebulosity. When we see light directly around nebulas, you might say that's when we see the blue reflection nebula, where it's a scattered light.
Yeah, as long as a healthy component of dark dust, yeah.
Where we're seeing the red stuff, I mean, that's hydrogen emission, and that's ionized hydrogen shining or emitting a characteristic red light, H alpha light.
Yep. See, I'm not going to say anything different. That's correct. This is interesting.
Curtis called it Eye of Sauron.
Well, that's the Helix Nebula. People call that the Eye of Sauron.
That's interesting there.
Yeah. Now we have this dark cloud between this and that nebula behind, so this is actually blocking some of the brightness that might be back here. That's neat. Okay. So we're going to make this NGC 7822, is it? Or 6822?
7822.
Okay.
Nice one, Curtis.
Yeah, he asked for this last time, and we ran out of time.
Yeah.
But we have this beautiful streamers of black dust that's just coursing through this region. It's really, really pretty. All right. So we'll take this one more exposure to make it go to an even 20.
And this is Cepheus, right?
Yeah. I am Groot. That's for you, Cindy Murphy. I am Groot. All right. Here's 20.
You see stuff in certain area of the sky, certain areas of the sky. After a while, you kind of get a feel for it.
Yeah.
I mean, if somebody just flashed me that picture, I wouldn't be surprised to find that it was in Cepheus.
Mm-hmm.
If you look at apods a lot, I can tell when it's going to be in Cepheus because it just has a real particular light and dark,
It does, doesn't it?
nebulosity look to it.
Yeah. That's interesting. All right. We're going to go to the Heart Nebula as our last object for tonight. And let's just go in night vision mode. Look where the telescope's pointing. It's actually leaning way over. Okay, well, we're there.
Thank you, Vera. They got me a microphone a while back, Vera. Everybody says I sound better now. I don't know if I necessarily agree with it, but everybody else likes it, so there you go.
Yeah, it was about time he had a microphone. Okay, the heart is in the other camera. We had a larger field of view. So now we're only going to be able to see a piece of the heart and not to see all of it. That's okay. It might be interesting to just do the fish head.
Oh, you got to get the fish.
That's probably all I can get in here. Let's just see if we can go to this section and see where this would be.
Looks like you'll have to make a mosaic when you want to look at the Heart Nebula now.
Oh yeah. Without a doubt. I think it's right there. I'm going to just drop it down because I think it's right there. Yeah, I think it's right here. Okay. Okay, so we'll just wait now. And we'll just do a quick 25-second shot because this is bright enough for this. Alright, off we go into the wild blue yonder. Now we'll live stack and delete the last shot from 7822, which is really pretty. So let's make sure. Yeah, look at that.
There's the fish.
You got it.
The fish head.
Yeah, see, this new camera is great because what happens is it's a smaller field of view and more pixels within that field of view, almost twice the resolution of the previous camera. So we're seeing much more detail in these objects right from the very get-go. Sam S says you need a microphone, Izabela. Do we have to get you one too? We got Darrell a Yeti. I think it was a Yeti, right?
Yeah.
Okay.
Yeti blue, if I remember correctly.
Oh, yeah. Oh, look at that. This is looking pretty. Let's see what it likes to be at. There we go. Beautiful region of space. Let's color correct. There we go.
And remember now that smaller field of view, this is just the top corner of the Heart Nebula.
I know. It's like, wow. You know, watch. Here's this square represents our field of view right here. Okay. And so if we select our telescope, I can center our field of view on it. We used to take a picture, it would be all of this. We'd see it all. Now, this is how much. And we're also twice the resolution in that small section. So it's really something. We'd have to do a mosaic that's got to be like, oh my gosh, probably like 1, 2, 3, 6... Probably a full 9 images, maybe 7 images, 8 images, to get this thing all in there.
Yeah.
Wow, that is just pretty.
I hope you folks see the fish head for what it is.
Well, see,
fishy mouth on the right.
Yeah, and you can see it that way, but if this is a dorsal fin, then it could be like a Pacific giant sunfish with a fin here, up there, and then I mean, that's a weird ass fish, man. Let me tell you.
The dark curved line going up and down and to the lower right across it.
Yeah.
That's pretty natural for his gill line right there.
Yeah, that's right. Yeah.
Like I've said before, that reminds me of my fish sculpture.
Oh yeah, you showed us a picture of that once.
Yeah.
Izabela was saying how her dog Sky has been sick. Well, my dingo, she has the worst gas of any dog I've ever had. And it's totally audible. You can hear it. She's like a little old lady walking across the floor. It's like, oh, no, dingo. Yeah. And it just drives me crazy. And sometimes if she scares herself with it, she go and runs away. Like, that was you, dummy. It's funny.
I've probably told this before, but an old friend of mine lived up in the mountains west of town. I'd go up and stay the night with him sometimes, and after dinner, we'd all sit around the dinner table and play Scrabble. And he had an old German Shepherd named Barney, and Barney loved to park himself under the dinner table, and Barney passed gas like you would not believe. We'd be sitting there playing Scrabble, and all of a sudden this horrible odor would come up, and everybody would shout, "Barney!" And he'd get up and he'd slink out from under the table and look at us with his big sad eyes, and he'd go away.
That is hilarious.
He is a heck of a dog, though. You know how German Shepherds can be.
Oh, yeah.
He's a very brave dog.
They are. This is looking nice. Starting to see the variations in part of the nebula here.
Yeah. And you're just
That's,
catching some neat stuff down to the bottom left-hand corner.
Yeah. But tonight we're doing the fish, and then we'll do the rest the other night. Let's just put this down out of the way, and let's actually make this full screen. There we go. I like my gestures. I like how that works. Okay. Now you can see some detail down here. It's really neat right here. This well, you can't see it right here. It is. Okay, right there. Okay, you see this right here. This is kind of a cool little area right there. Wow. Yeah. Definitely going to be doing a mosaic of this at some point. Absolutely. Okay.
That is really curious looking down there.
Yeah, so what I'm going to do is I'm going to do this. Fish head region. Alright. And we'll save it after this next one comes in. 17 exposures. Save exactly as seen. Remember, all of these go up on skytourlive.org. You go up there, you can see this very picture moments from now. Whenever you feel you want to see it, it'll be there for you. Okay. So now what we'll do is, first of all, let me redock this. Okay. And let's go back to our night vision mode. And I'm just going to go down and over and pull up this stuff right here that is pretty interesting. We're going to see that. So this wasn't the final object. Duh. When is it ever? Okay. Okay, so now what we're going to do is let's bring back our telescope. Okay. And let's head east a little bit. Head south a lot a bit. Okay. That's good. All right. And then we'll set up to do another 30-second shot in here after we get our guide star. I tell you, it's hard to stop once you get started. Okay. Off we go. There's our fishy. And now we clear and wait for the first one to come in. Okay, this is going to be the area of interest right here. This is kind of near the central region of the heart.
Huh? Oh, is this that area that was at the bottom left-hand corner?
Yes.
Okay.
So it's right here near
Yes.
the part of the heart. Yep. And it's going to be really pretty. Okay. What else is there? There's a lot in there.
Cool.
Yeah.
The Wizard with the Torch, Izabela says. Izabela, I see that, I think. Is that what it's
yeah.
called?
I think she's making that up because I've never heard that.
I don't think
But
I've
I
ever heard
see
of it
it.
either, but I see it.
Yeah. Let's add some contrast. That's a very hot, unforgiving region right there.
No, it's sort of like Gandalf when they were in Moria and he held up his staff to make light for them to see by.
Is this his arm?
No. Or, well, maybe it is. I see two. I see two wizards.
So, one here and one here.
Yeah.
And that's the staff? Those stars are the staff?
Well, if the lower thing is the wizard, then the upper wizard is his staff.
Okay.
Somebody messaged me.
Let the pareidolia begin.
Oh,
What?
somebody sent me a picture of a dog.
Oh. How nice. now you can see this complexity in here. It's really pretty.
Yeah.
And look at this complexity in here. That's really complex in here. We'll
I
catch
sort
that
of see
look at
it's
that.
like a Z or a 7.
Right here?
No, right where you were just pointing, right there.
Oh,
That's
here?
the top of. Yeah, you see it horizontal
this
across
here?
the top, then slash down to the lower left, and
This?
then maybe another bar like at least a 7, maybe a Z, maybe sort of a 2 shape.
Yeah, like this, over and down, and top, and boom. Yeah.
Izabela sees a roaring bear.
Mm-hmm. It's in Pareidolia. Wonderful. Oh,
Really
yeah.
cool.
Yeah. Yeah, this camera allows us to dig into the complexities where we couldn't perceive it. Couldn't perceive it before. Very nice. Isabel's right. It's a Rorschach test.
Yeah. Exactly.
How are you, Benjamin Isabella? I haven't said hi to you tonight. Am I a mistake? Okay, let's do what I did before. Let's move that. And let's get rid of this and allow ourselves to zoom in. Look at that. We'll just do this. Look at that detail up there. I'm talking in particular about this beautiful dark nebula right here. You see this stuff? That stuff right there is really, really phenomenal. It's got that depth to it. It's got a long strand that goes several light years in length. This is really cool stuff. Let's see. Where does it want to be now? Okay, that's actually kind of helpful. Because now you can see some of the subtle detail in the background. We're going to do 15 of these.
The wizard I see holding his staff up is the lower bit there. The upper thing, I think you saw as the wizard with the light that was a star. That looks more like a dwarf to me.
Okay. Very cool.
That is really something.
Yeah, this is. You can now see this is a. This whole section is a dark nebula swirl.
Uh-huh.
And you can see this is a beautiful pillar-y kind of thing. Wow. Well, there we are. I hope you guys enjoyed this tonight, because Trizzle, Trazzle, Truzzle, Trom. Time for this one to come home. Help, Mr. Wizard!
Oh,
Who
yeah.
remembers that? Tutor
I
the
remember
Turtle.
that. Who?
All right. Tutor the Turtle.
Okay.
You don't remember that?
I don't remember Tutor the Turtle. I remember Help, Mr. Wizard.
Yeah, he was the turtle was saying that to the wizard.
I thought that was a kid.
Well, it was Tutor the Turtle.
Okay.
And then the wizard would say, Trizzle, Trazzle, Truzzle, Trom. Time for this one to come home, and brings them back.
Remember that one too.
Yeah, that was all the same show. Tricia Ferreira, good night. Thank you for coming. And this was a lot of fun. Beautiful imagery here. We'll draw this out later. It's going to be gorgeous. So, just remember these beautiful regions in the universe. They're just spectacular. We're going to go to 20 on this, and then we'll shut it down. You shall not pass. That's right. Okay.
Exactly.
All right, here we go. Done and done. Thank you, guys. Thank you for coming out and seeing us tonight. We had a good time with y'all. We're going to kick this out of here. This is just so beautiful. Let's bring back the telescope here. There we are. And let's go and do our night vision thing again. And then do that. See, you can't see much of it even with a very sensitive camera. You have to do a time exposure. Wow. All right, well, guys, thank you. I hope you enjoyed it. If we did, we look forward to seeing you again. And we'll stream in the next day or two again, because we just can't stop. I can't stop. Anyway, Darrell can probably stop. I can't stop.
Good night, everybody.
All right.
Lewis Ta asks, Mark, are you streaming the solar eclipse next week? If I had to guess, no?
I don't think I will, because I don't have a way to show it from there. And from here, it's not visible in Connecticut.
Yeah.
So,
yeah. From Arizona, too, it'd just be a deep partial.
Yeah.
Probably about like what I'm going to see here. 80. I think it's about 80% covered from here.
Yeah, yeah. All right, guys. Well, you have a good evening, and we'll talk to you again. So we'll see you later. And remember, when you go outside, keep looking up. You never know what you're going to find. Good night, everybody.
Good night, everybody.